Hello, good evening my 12th standard students. Welcome to the second class of light waves. We have seen what light's sources are, the different types of wavefronts and the Huygens principle in the first lecture. Today we are going to see the basics of Young's double slit experiment in the form of interference. And this is basically partly a revision of your 11th standard waves chapter, but it is very helpful, which basically lays your foundation blocks for studying Young's double slit experiment as well as diffraction. So let's get started with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome my bacha log. Hello Sai, Mugesh, Aishwarya, Ganpati, good and bold girl. My god, what a funny name, and welcome aboard. Hi Arnold, hi Chitra. Chitra, you're still blocked. I will just get in touch with our admin and make sure that you're unblocked. Don't worry about it. Okay, so those of you who do not know me, a quick introduction. My name is Shreyas and I did my graduation from NIT Nagpur. I qualified JEE back in 2005, almost got full marks in JEE Physics, and then I decided to switch over from my regular software job to teaching when I started seeing that many of my students are scoring really well in JEE. And when I started producing amazing ranks, that's when I took up teaching full time, and ever since then there is no looking back, and more than 10 years of experience comes with lots and lots of mentorship. Thousands of students being mentored under me and lots of ranks, under 100 all India rank produced by me. So I feel really proud to tell you all of this because it's fun. This has been an amazing journey, and it's always interesting to get to know so many lovely amazing students. And on YouTube I am here to make sure that this joy of learning spreads throughout the country and across the borders. Welcome aboard. Hi Faza, hi Vishnu. Welcome. My next lecture will be YDSE. Yes, Vishnu Priyan, correcto. Hi Muhammad Rafi, nice name. I'm pretty sure you would have heard of the famous legendary singer Muhammad Rafi. I love his songs. I'm so glad we have Muhammad Rafi too in our lecture. Hi Ramya. Ramya, I do not know much of Tamil, bacha. Okay, so let's get going. And before we go ahead, do not forget to do one small favor. Go smash the subscribe button in case you are new to the channel. The reason why I tell you to do this is so that you do not miss any of our classes. And this is a dedicated English medium channel for all the students preparing for entrance examinations like JEE and then KVPY and CBSE, everything. Also, do one small thing. As a Guru Dakshina, go smash that like button down there. Alright, so let's get started. I hope you are all excited, and I can see all the fire and the yos in the chat box. Hi PL, good evening. Hi Mitran, good evening. And a quick information for all of you, those of you who are in the final leg of preparation for CBSE and who need help for covering up their syllabus, or they need that final boost to improve your ranks and your percentages, and you want to start your KVPY journey in case you have not prepared much, because immediately after your CBSE term 1 you might have your KVPY, and immediately after that you might have your first attempt of JEE mains. If you want to revise the syllabus, if you want the material, the assignments, the test series, and if you are maybe not so satisfied with your coaching, or you need that extra help, that extra push from just sitting at home without traveling anywhere, then I would suggest please consider Vedantu. The reason why I tell you is because you not only get your live classes, but also they are recorded. You get your regular test series, you get analysis report cards right at your fingertips. Not just that, you get prepared for variety of exams under one price. There are no special charges for these separate courses. It's all like a subscription. And I would suggest you guys to check out the link in the description box where there is pro subscription joining link. You can click on it and use my coupon code SHHPRO to get 10% off. You have 1 month subscription as well as the year-long subscription till you write your JEE Advanced. So go ahead, try it out, and I'm pretty sure you will enjoy it. So get started with your learning journey today itself. Very good. Thank you, Aishwarya, for liking it. Nandini, yes, the next class, I think I mentioned that it will be YDSE, I guess. Oh, yesterday I sent the answer. Is it correct? I'm not sure which session's answer you're talking about. Ganpati, I'm so proud of you, bacha. So proud of you. You got really good marks, and I really hope it improves even more, by the term 2 and by the time you write your JEE mains examination. Last lecture, let me tell you, I covered Huygens principle as well as the basics of light, waves, as well as the types of sources. You can see it over here. This was lecture 1. And every lecture I ask you, to solve some homework questions. So make sure that you solve it and post it up in the comment section out here. Looks like the questions were tough and not many people solved it. But anyways, so please make sure that you post the answers in the comment section so that I can read it out in front of you, and you might feel really proud that your name is taken right in front of everyone. All right, so do that. So let's get started with the first concept over here. Today's lecture, like I said, it's all about interference of light. In general, these principles are also applicable for different types of waves, be it transverse, be it longitudinal. These concepts are very similar. You will see it's more like a revision. First, what is coherent and what is incoherent sources? See, coherent means it's in sync. Incoherent means it is not in sync. Now, the thing is, we need coherent sources to study interference, not incoherent sources. I'll tell you using a quick example. Imagine, see what is interference, I'll come to that briefly, but before that, imagine there is a source of light, let's say I call it S1. It is generating a wave like this. We have another source of light, S2. It is also generating a wave maybe like this. Now, when there is a crest here, there is a trough, and when there is a trough, there is a crest. So I know for sure that no matter at which point of time I look at these waves, that yes, when there will be a trough, there will be a crest on the other wave. So it's in sync. Similarly, imagine if this wave was like this and this wave was like this. If there is a crest here, there is a crest. If there is a trough here, there is a trough. I know later on, at some other point of time, if there is a trough, there will be a trough. It's in sync. I can gauge, I can, predict it very accurately. There is no doubt out there. But imagine this. This is a source S1 and there is a wave like this, and S2 is a source like this and there is a wave which is going like that. Now, when there is a crest, maybe there is a trough. When there is a trough, there is a trough. When there is a crest, maybe there is something else. So it's unpredictable. It's not matching. It's not in sync. So it's very essential to understand how the waves merge, interfere with each other. We need to predict what is coming with the first wave or what is coming with the second wave. We need to see how, they are related to each other. The relationship must stay constant. And that's the meaning of coherent sources. In incoherent sources, the waves are not in sync, and you might see that when a crest comes, sometimes a trough might come, sometimes a crest might come, something else might also come, as the wave progresses. So this is how coherent waves might look like from more than one sources, and incoherent sources might look very, very weird. Either their wavelength might be same, but their phase might keep on changing. The phase might keep on changing, and sometimes there could be, starting at different times, and they might have different wavelengths. One might be more, one might be small. So, they do not perfectly match over each other. I hope this is clear. Yeah, maybe someday it will, probably I can take it up as a special class. Is that understood, my warriors? Hi, Gokulnath. Good evening. Welcome aboard, bacha log. So, Reshma, I guess we should expect around, 4 attempts. Let's wait and watch. Yep. So no problem, Shivam, even if you have not attended the first class, most of it will be still understood. But yes, so what is the main thing about coherent sources? They are in sync. You can predict. Incoherent, you cannot predict. Sometimes they match, sometimes they do not match. So it's completely unpredictable. The best examples of coherent sources of light is nothing but laser light, or we are going to see another way of getting coherent light. But the light that you usually see around you, the light that you see around you, like this one, this light is incoherent source of light. I mean, you cannot expect the light which is coming from here and here is in sync. No. Although it is the same piece of light bulb, understand the light which is generated here and here will not be in sync. Sometimes the light wave coming here may be out of phase, or they might be completely opposite, as in this might be crest, this might be trough. After some time, maybe there is light coming here, but there is no light coming for a brief moment, maybe for a nanosecond, and then suddenly the light comes from here, and then there is no light coming from here for a brief moment of time. So you cannot predict about, how the light waves are coming from this entire source of light. So this is incoherent. But laser lights are known to be, coherent sources of light. There is another way of looking at coherent sources, and that is derived sources. Derived as in, it's coming out from the same singular source. It's derived from a primary source. Look at it. These are wavefronts. They are hitting two slits. You can see two slits over here and two new sources. These are secondary sources. This is like wavefronts. They hit one slit here and here. So there are two slits, and you can see new wavefronts being generated from here in sync, because you can see that this entire wavefront hits both the slits simultaneously. Hence, both of these sources, which are now the secondary or the derived sources, will be coherent. Is that clear, my warriors? Put up a thumbs up, put up a yo, put up a smiley if you got this. Okay, so this is a part of light waves. Yep, light waves. Yep. So Young's double slit experiment, it's that chapter. Very, very important chapter. So a primary source can give coherent sources if you derive two or more sources out of it. So derived sources are always coherent. Keep this in your mind, because everything is in sync, everything happens together in case of derived. You derive it from the primary source. And here is your first question up on your screen. So two sources of waves are coherent if both have same amplitude of vibrations, both produce waves of same wavelength, both produce waves of same wavelength and also have constant phase difference, both produce waves having the same velocity. Which of the following is the condition for the waves to be coherent? You will see this again and again. You will see this again and again. Okay, come on. Come on, my warriors. Think about it. Suhani, can you be more specific? What is the meaning of in sync? Oh, no. Sync as in synchronization. S-Y-N-C, not that sync. That sync that you are talking about is that different sync, that wash basin sync. No, I'm not talking about that sync. I'm talking about this wala sync. Synchronization. So if this is, one wave, I know the second wave is very much predictable. It's linked to it. There is a precise linking. So this sync is what I'm talking about, not S-I-N-K. Okay, cool. Great. Okay, most of you are saying C. Shivam saying C. Salkochan also saying C. Come on, my warriors. Think carefully. Many of you are saying C. Is it? Okay, let's figure this out. Yes, you guys are right. Perfect. Very good. Proud of you. So both waves must be of the same wavelength and they must have a constant phase difference. Look at it. If this is one wave, okay, this is one wave like this, and the second wave, maybe it does not start exactly here, but maybe right after this, it's still in sync, or rather it is coherent, because I know just after this crest, the next crest follows. Just after this trough, the next trough follows. After this crest, just after some time, there is a crest. Just after the trough, the next trough follows. So there is a precise gap which is maintained. Imagine this wave. Okay, imagine this wave which is not having the same wavelength or the same phase difference. Imagine this, like this, and then like this. It's obviously not predictable. I mean, they are not in sync. The red and the green, or the black and the green, are definitely not in sync. So the wavelengths must be same. If the wavelengths are different, gone. It is not going to be in sync. It is not going to be coherent. Beautiful. Let's see the next question coming up on your screen. Oh, no problem, Suhani. It's okay. Happens. Don't worry. You are allowed to make as many mistakes as possible. Yep. Sir, have to taken light chapter in Pathfinder? Yes, light is a chapter for 12th standard students and it is a part of Pathfinder, which is a long-term series on YouTube on VEnthuse for all the 12th students who are going to write JEE in 2022. This chapter is in term 2, but it is very important, and since we had some time, so that's why I thought of covering this chapter, right before your term 1 examinations. So for light sources which produce the following 4 waves, 1, 2, 3 and 4, superposition of which 2 waves can give rise to steady interference? Which 2 waves do you think can combine together to give you a steady interference? Think about it carefully. 1 and 2, 1 and 3, 1 and 4, 4 and 2, 2 and 3, 2 and 4, I don't know. One of the pairs will give you a steady interference, as you might see. Okay, think about it. Dakshin, you're free to join, but I prefer you watching the 11th standard classes regularly. I know you're regular there, but yes, you're free to watch these classes. Anyways, this will be helpful for you in 1 year and also in the chapter of sound waves and transverse waves, which is there in 11th standard. Oh my God, Ramya, really, I'm so humbled. I'm so happy that you're in 8th standard and you're able to understand this. I'm so glad. I'm so glad. Okay, now this is something which probably needs the knowledge of SHM of 11th standard. So if you are in 11th standard or below, maybe if you have not studied SHM, you might find this little bit tough, but otherwise this is easy. I'll tell you what you need to do. See, which 2 waves gives rise to steady interference? Steady interference means if one wave is like this, the second wave, okay, the second wave should have the same wavelength. It should be in sync. If they are in sync, okay, if they are in sync, or basically they should be coherent. If they are coherent, only then it can produce steady interference. How do you make sure that their wavelengths and their phases are, constant? Very easy. Just check their frequency. This is their frequency, omega. Any expression of wave or oscillation which has that omega will give you that angular frequency. Here it is omega, here also it is omega, here it is 3 omega, here it is 2 omega. These 2 waves have different frequencies than omega, whereas these 2 have basically the same, they have the same frequency. If they have the same frequency, that means they have the same wavelength. If they have the same wavelength, that means they are coherent. So 1 and 3 should be the answer. That means option C. Correcto. Okay. Now those of you who do not know what interference is, that's the next slide going to be. Don't worry, Shivam, we are going to talk about interference in a bit. Yes, the correct answer is C because their omegas was same. Imagine if this expression had 2 omega, then 2 omega and 2 omega will be in sync. These 2 frequencies or these 2 waves will be coherent. If this was 3 omega and this is also 3 omega, then these 2 waves will have same frequency and same wavelength. So they too will produce steady interference. Is that understood? So check for waves with same frequency and same wavelength. They will produce constant interference. It will not change with time. That's what is important. Okay. Now, this next concept of path difference is very important for solving many questions. Let's talk about it before we actually jump into what is interference and superposition. Hold on there. Now, path difference and phase difference. See, you will have 2 or more sources in all the problems today. Yes. Whenever 2 sounds, whenever 2 lights interfere, meaning you will have 2 or more sources, they are merging, they are collecting, they are, colliding with each other at some place. The most important thing for solving the problems, you will see most of the times is either phase difference or path difference. I'll tell you what it means. Imagine, this is wave number 1. This is wave number 1. Okay, this is wave number 1. This is wave number 2. And this wave is exactly replica of wave number 1 as well. When there is a crest, there is a crest. Trough, trough, crest, crest, trough, trough, crest, crest. They are perfectly in sync. There is no difference between their start and their ends. And we all know one wavelength, okay, one wavelength, basically this is 1 lambda, corresponds to 2 pi radians of phase. Very, very important. 2 pi radians of phase is corresponding to 1 wavelength, and 2 pi radians means 360 degree. Pi radian is 180, 2 pi radian is 360. Why am I saying it is 360 degrees? Because if one chooses 2 points which are 1 lambda apart, both of them will go up and down together. Both of them will go up and down together, so they are perfectly in sync. So they are basically having a phase difference of 360 degrees, which is 0 degree. 0 degree, 360 degrees is same, because both of them are going up and down, as if they are replicas of each other. So when you have two waves which are going up and down together, their phase difference will be 0. Okay, their phase difference will be 0. But imagine this third wave. Imagine this third wave. It starts exactly from this point. Okay, it starts from this point and like this. You can see that there is a gap. You can see that there is a gap of exactly 1 wavelength, but after that it is exact replica. So this is exactly 1 wavelength. So what is 1 wavelength? 1 wavelength is nothing but 2 pi radians. So in this case, the phase difference is 2 pi radian. You can see that there is a gap of 1 wavelength, so that is basically 2 pi radian. Imagine a fourth wave like this, and let's say it starts after 2 waves right over here. So you can see that the gap over here is 1 lambda, 2 lambda. 2 lambdas means 4 pi radians. 1 lambda is 2 pi. 2 wavelengths is nothing but 4 pi radians. So this is 2 lambda. So here the phase difference will be 4 pi radian. Is that understood? Is that understood, my warriors? Yep. So now, no, it is not pi radians. That's wrong, Suhani. 360 degrees is 2 pi. So 1 wavelength corresponds to 2 pi radians. Okay. Half the wavelength is pi radians. Half wavelength is pi radians. Now observe this. I'll just remove this part and observe. Imagine a wave number 3. It starts right over here. Okay, imagine I push this exactly over here. Okay, something like this. Okay, perfectly. Now observe, when there is a trough, there is a crest. When there is a crest, there is a trough, and you can see the gap between these two waves. This wave starts from here. Can you see this next wave starts exactly after half of the wavelength? What will be half of the wavelength? Half wavelength is nothing but pi radian. Half wavelength is nothing but pi radian. If you shift it further, like you can see, by more half wavelength, okay, so then you just get this thing over here. Okay, so this is 1 wavelength and the phase difference becomes 2 pi radian. Now you shift it even further, let's say by more half of a wavelength, the fifth wave. Okay, you start it right over here. Okay, imagine this. So if you see this gap over here, half wavelength, half wavelength, half wavelength. So this is 3 times wavelength by 2. 3 times wavelength by 2. Can you visualize this? Can you see by how much I have shifted this? So 1 wavelength and a half. It's 1.5 wavelength. So after that, I start the next wave. In that case, the phase difference will be, think about it. Yes. So Shiv Kumar, if you have watched SHM, then you will be able to visualize how 1 wavelength is 2 pi radians. Okay, if you have watched or studied the 11th standard waves, so then it becomes easier. Correct, Suhani, this will be 3 pi radians. Yes, this will be 3 pi radians. So one way to visualize it is basically think of circular motion, and the projection of circular motion is basically SHM. That's how you can visualize it. So I would advise you to watch my flash series or my previous 0 to hero series of waves and SHM. Yep. So this will be 3 pi radians. Yep. So now this difference between any two waves is called as path difference. So when one wave starts and when the second wave starts, so that difference is called as the path difference. A path difference leads to phase difference. What does a path difference lead to? Phase difference. Keep this in mind. So to give you a generic thing, look at this. If one wave starts here, the next wave starts here, this is nothing but called as the path difference. It's the path difference. The usual symbol for that is delta x or just delta. Okay, so that's the path difference. What does a path difference lead to? It leads to something called as the phase difference. What's the symbol for phase difference? It is delta phi. And we all know one wavelength is nothing but 2 pi radian. So now think, if one wavelength is 2 pi radian, delta x distance or difference will be how many radians? Simple, unitary method. Come on, my warriors. One wavelength is 2 pi radians. So delta x is how many radians? Think about it. This will be nothing but, come on, this will be nothing but 2 pi radians is per wavelength into delta x. This will give me delta phi. Very important relationship. Very important relationship. Understand this. Very good. 2 pi by lambda is radians per wavelength or radians per meter into the number of meters. Will give me how many radians does this delta x cause? Exactly. Very good. All right. Very good. Excellent. All right. Now, if you have understood till here, you will also understand why path difference becomes significant. Observe this. There are two sources of light, sound, any wave. This source and this source generate the wave simultaneously. Okay, they generate the wave simultaneously. But you are at some random point, and at that point you see maybe that point is closer to source 1 and maybe it is far away from source 2. That means although I might generate crest simultaneously, the crest may not reach here simultaneously. I'll repeat, the crest generated here might reach first and the crest generated here might have just reached here. Don't you see there is some path difference over here? There is some path difference over here. Don't you see that there is a lag? You know, the first wave reaches, the second wave reaches after some time. That lag has been basically, it creates phase difference. So that lag in the distance is nothing but the path difference. You can see there is a lag over here. One wave is front, one wave is behind. You know, it's basically a lag in distance. So this lag in the distance or the difference of the distance is traveled by two waves before interfering, before meeting, is called as the path difference. I hope that is clear. Now in this situation, there are 7 wavelengths which are fitting here, whereas there are 9 wavelengths fitting here. So in this situation, what should be delta x? Delta x will be 9 lambda minus 7 lambda, which is nothing but 2 lambda. So 2 lambda is the path difference for this numerical. And how much is 2 lambda in radians? So in radians, think about it. 1 lambda is 2 pi radians. So 2 lambda will be nothing but 4 pi radians. Is that understood, my warriors? Ramya, maybe I can take up that doubt later on. Let's focus on light waves right now. Yep. Very good. Is that clear? Perfecto? Understood? Yeah. So what have we learned till now? Coherent sources are sources which are together in sync and their phase is constant, their wavelengths are constant. When 2 or more light sources produce waves, they meet at a certain point, but they might not arrive simultaneously. If they arrive, one later than the other, it creates a lag in distance, okay, like the one generated here. That is called as the path difference. A path difference leads to phase difference, and this is the formula for the phase difference. Very good. Excellent. So I have kept the formula for all of you. Let's start solving some questions right on your screen over here. The path difference between two wavefronts emitted by two coherent sources of wavelength 6,000 angstroms is 900 nanometer. Okay, 900 nanometers is the path difference for lights which are coherent, okay, and the wavelength is 6,000 angstrom. The phase difference between the wavefronts at that point where they meet is how much? Let's try to figure this out. It's very easy. Okay, figure this out. Come on, my warriors. Think. What should be the correct way of solving this? It's very easy, very straightforward. You will get it. And trust me, those of you are joining in even in late right now, and even if you have joined earlier, please stay till the end, because we are going to build right from the basics of interference sources and all of that, and slowly move on to complex problems of interference and path differences, and end the class with optical path length. This will be the foundations for your next class, which is YDSC. Come on. Okay, let's figure this out. The wavelength of the light is 6,000 angstrom. 6,000 angstrom is 6,000 into 10 to the power minus 10 meters. The path difference delta x is given to be 900 nanometers, which is 900 into 10 to the power minus 9 meters. The question is on phase difference. We all know what's the formula. Hello Sri, hello unknown. Don't worry, even if you're late, just watch it. Okay, just stay till the end, and if you want, you can even go back in the live session and catch up wherever we are. All right, cool. And those of you are watching it recorded, make sure that you pause the video before you look at the solution. All right, so del phi we know is nothing but 2 pi divided by lambda into del x. That's the standard formula which I just gave it to you. So 2 pi divided by wavelength, which is 6 into 10 to the power, these three zeros and this 10 to the power minus 10 will make it 10 to the power minus 7, right? These three zeros and that 10 to the power minus 10, and delta x over here, that will be nothing but 9. There are two zeros, so into 10 to the power minus 7. Interesting. So 10 to the power minus 7, 10 to the power minus 7 goes, 2 and 6 goes, this will become 3. 3 and 9 goes, this will become 3. So only 3 pi is remaining. You can see over here. So the correct answer should be 3 pi radians. Yup, 3 pi radians should be the answer. Very good. Very good. Excellent. Now, there is a term used for certain phase differences. You might not be aware of it, but let me tell you what is that term before going ahead. Remember one thing. Whenever the phase difference is 0, 2 pi, 4 pi, 6 pi, basically any even pi. See, 0 degrees if it is here, 2 pi is 360 back there. Again, 720 is back here. 6 pi is also back there. It's the same thing. So, 0 degrees is same as 360 or 4 pi or 6 pi or any even pi. They are said to be in phase. It's like having two waves pointing in the same direction, and their angle between them, the angle between their phasors is 0 degrees. Similarly, understand, if you have a phase difference of pi, which is 180 degrees, or 3 pi, or 5 pi, or in general any odd pi, then it is said to be out of phase. What is it called? It is called out of phase. The angle between them is 180 or 3 pi radians or 5 pi radians, any odd pi. I'm very good, Rishabh. Join in. Okay, very, very important. Out of phase and in phase. Let's talk about interference more now. See, what is interference? Simply put, it's meeting of waves. Now, when two objects collide, they produce dhamaka, they produce energy, there is momentum conservation involved, elastic, inelastic type of collisions which happen. So, if one small object and there is another big object, they collide, they do not pass through each other. But waves are something different. Look at this. There is one wave which is coming from there, another wave coming from here. They pass through each other as if the other wave was not there. And this is always true for any wave, be it light, be it sound, be it wave on a string, or even earthquake. So, for the other wave, The other wave is like a part of the string which just climbs over that string, which is probably not straight. And this is true. Every time waves meet, they just pass through each other as if the other wave is not there. But when they meet, each wave has its effect. So if wave number 1 comes at place 1 and the other wave also comes at the same place, each wave will add up their effects. And what you see at the meeting point is the interference. You see the superposition, superimpose, meaning you impose one wave over the other, so that what you get is the resultant wave. You get the resultant wave. So superposition principle says when two or more waves meet at a point, it's not only for two waves, it can be for 3, 4, hundreds of waves meeting at a point. Each of them will be like, hey, even I want my say. Other wave will be like, even I want my say. Even I want my importance. Every wave will be like, I want my importance to be seen. Every wave will superimpose its values over each other, and the wave, the net wave that you will be seeing is the net resultant displacement of all these superpositions. So it's just the sum of all the displacements that each wave will try to produce. So in case of light, it's not displacement, but it is electric field. Because we all know what is light, it's an electromagnetic wave. So light 1 comes, it will have some electric field and it will have some magnetic field. Light 2 comes, it will have some electric field and magnetic field, or their electric fields and magnetic fields will add up together to produce the resultant electric field. Is that clear? Is that clear? Think about it. Red is most powerful. I would say red is having the longest wavelength because you can see red light from a large distance. That's why it's used to symbolize danger or warning. And violet light is having the shortest wavelength and it does not travel too much. Okay. Now there are two types of major interference, and then we'll go to the third generic type. Yep. So what are the two basic type of interferences that you can get? The two types of interferences that you can basically get is constructive and destructive. And the third type, which is neither of them, is called as intermediate interference. So basically you have three types of interferences: constructive, destructive, and when it is neither of them, then it is called intermediate interference. Constructive and destructive is very easy to visualize. Imagine the crest of one wave comes with the crest of the other wave. Two crests come at the same time. When they add up, it will become a big crest. When the troughs come, trough and trough will become a big trough. So that is adding up positively. That's constructive. Imagine this. A wave's crest comes, the other wave's trough comes. They will nullify each other. They will cancel each other, maybe fully, maybe not fully, depending on how big each crest or trough is. They are cancelling, they are destroying each other. So that's destructive interference when crest comes with trough. Is that understood? Similarly, the third type is when you have a crest, but the second wave's crest is not there, the trough is not there, it's something in between. Something between the crest and trough. That is called as intermediate interference. And let's see that over here. Observe this. This is wave number 1, this is wave number 2. Crest, crest. Okay, you can see that. This is midline, midline. This green point, green point. It's the same thing. This is no displacement, no displacement. You can see that. Okay, this is trough, this is also trough. So each wave will have its effect. Wave number 1 has amplitude 1. Wave number 2 also has amplitude 1. When you add both these waves, the resultant wave has an amplitude 2 because their amplitudes have just got added up. You can see that. You can see that. Very good, very good. Okay, so in constructive interference, can you see, my warriors, that the amplitude of the resultant wave is amplitude of wave 1 plus amplitude of wave 2. So this is the first thing that you can see for constructive interference. Second thing, the crest, trough match. Crest matches with the crest of the other wave, the trough matches with the trough of the other wave. That means, what do you think is the phase difference between them? What do you think is the phase difference between them? What do you think can the difference of the phase be so that they merge perfectly, crest with crest, trough with trough? It can be 0. Not just 0, but it can also be 2 pi and in fact any even pi. Pi basically. So any even pi will do. Any even, not just 0, because 0 is same as 360, 720 and so on and so forth. I hope that makes sense. Not just that, 180 will not do. Now 180 will not do because see, if this is 0, okay, 0 degrees, then what is 2 pi radians? Think about it. 2 pi radians means you leave one wavelength and then start the wave from here. So this is 2 pi radians phase difference because you have left one wavelength. Okay, so similarly you can leave two waves and then start it. So this is my wave, okay, like this. So after 1, 2, after 2 waves if you start it, still crest, crest, trough, trough, crest, crest, trough, trough, meet. So this is still constructive interference. So all these phase differences are okay. And what are the path differences that are valid? 0 is valid, lambda is valid, 2 lambda is valid. In general, any n lambda will give you constructive interference. Any integral multiples of wavelength, you leave a gap of n lambda so that you will see that both the waves crests and the troughs match. So then you will see it is going to be constructive interference. Is that clear? 1 pi is half of 2 pi and 2 pi is one wave. Correct, Ramya? Very good. Yes, that's very true. Very true. Understood? Clear? So, any gap of any n times wavelength will always create constructive interference. Their amplitudes get added up. And the phase differences can be 0, 2 pi, 4 pi, 6 pi, 8 pi, basically any even multiples of pi. And path differences 0 lambda, 2 lambda, any n lambda. Very good. Now destructive, it will be very similar. You can observe this carefully. So just look at this, okay? This is one wave, this is the second wave, crest, trough, trough, crest, exactly out of phase. And because their amplitudes are same, you can see the resultant is 0. There is nothing over there. But if this was 2 and this was 1, then 2 minus 1 will give you 1. Here both of them are 1 and that's why they are perfectly cancelling out each other. So the result is 0. Okay, so that's how you can cancel out. And by the way, this is the principle of working off your noise cancelling earphones. Most of you would have heard Bose noise cancelling earphones or MI noise cancelling earphones. What does it do? You are hearing some noise from your surroundings. Some child is screaming, people are quarreling, somebody is shouting, there is some gentle breeze, there is somebody honking. All these are noises. You don't want to listen to that. You want to listen to music. So what these speakers do or what these earphones do is they create a sound which is exactly opposite in phase of that external noise. What does it do? It creates exactly opposite sound of the external noise. So the noise that you hear plus the noise that you get from the speaker or the headphone will cancel each other and you will not hear anything from outside. Isn't this interesting? Yep. Yes. In constructive, all are in sync with each other. Yes, Suhani. Will the intensity be squared? Yes, unknown. I'm coming to the intensity part in a bit. Yep. Yes, very good. Very good, Ramya. You said it. They generate another noise to shut the noise, but that noise is opposite in phase. Correcto. Hari, all of the students out here are preparing for JEE. All the best, Nikhil Krishna. And I'm so glad that you are still here watching the classes, and that's the true spirit of every JEE aspirant. Irrespective of what exams you have, you still attend the classes without any fail, even if you are watching it recorded. Great. Now, in case of destructive interference, what one can say is that, the amplitude of the resultant is A1 minus A2. That's number 1. Okay, A1 minus A2. Number 2, you can see that the phase difference between them, because they are out of phase, and remember what is out of phase? Pi radians, 3 pi radians, essentially any odd multiple of pi. 180 degrees. They are opposite to each other. When there is crest, there is trough. When there is trough, there is crest. Exactly opposite. And the path difference will be careful, this is lambda by 2, 3 lambda by 2, in general, any odd times lambda by 2. Very, very important criteria. I'll make you visualize this. Imagine this is a wave. I'll just show it over here. Okay, this is wave number 1. Okay, you start exactly after half a wave. Half a wave. Wavelength by 2 is half a wave. You start from here. So you can see what is happening over here. Trough, crest, crest, trough, trough, crest. So exactly half a wave. If you start after 3 times half wavelength, 3 times half wavelength is half wavelength, half wavelength, half wavelength here. So you start exactly here. This will also do. Okay, you can see that. So trough, crest, crest, trough, trough, crest. So again it will create a destructive interference. So basically whenever the gap or the path difference is any odd times wavelength by 2, then it creates destructive interference. The waves are out of phase and the resultant amplitude is the difference of the two amplitudes. Yep, very good. Headphone is really bad, Anna. Yeah, it's not that great to use it continuously. Yes, you should constantly remove it and then wear it because it might definitely create some kind of infection for sure. Yes, you can relate sine and not cos graph. Wrong, Suhani. Sine and cos graph, the phase difference is 90 degrees. Sine and minus sine graph. Okay, sine and minus sine graph, they have a phase difference of pi. So if this is sine, this is minus sine. Sine and cos, they have a phase difference of pi by 2, which is 90 degrees, much different than constructive or destructive interference. All right. So this simulation shows exactly whatever I have explained to you. Observe this peacefully. Observe this peacefully. So you have 2 speakers or 2 sources of sound, light, doesn't matter. Look at this. Slowly the difference between their path will change and how the interference types also changes. Right now they were in sync. One of the wave goes ahead. You can see it has exactly moved by half a wavelength. This is exactly half a wavelength. So trough, crest. Earlier both of them were in sync. Now trough, crest, crest, trough, destructive interference. Can you see that? This is exactly lambda by 2. Lambda by 2. Both of them will cancel each other. Okay. And same thing. Look over here. Look over here. Earlier they were in sync. But when you move one of the source exactly one wavelength ahead, then it's as if you're continuing that wave and it will make it constructive interference. Crest, trough, matching with each other. Observe this for the next 10 seconds. Convince yourself and put up a yo, put up a smiley if you got this. I will leave you to this. Definitely, Nikhil, it will be very useful. Hi, Pasupalati, Dhanush. Good evening, bacha log. And if you're loving these lectures, do not forget to smash the like and also hit the subscribe button. Lambda is the wavelength. Lambda in the second case is the path difference. In the first case, the path difference is wavelength by 2, half the wavelength, exactly half the wave. One crest or one trough, remember, is half the wavelength. One crest and one trough together is one wavelength. Correct? Exactly, Ramya. Very true. Excellent. Excellent, Ifaza. Very good. Very good, Dhanush. Let's move on to the generic, expression for interference of waves. All right. So, in general, when you have 2 waves, something like this, let's say this is wave 1. Okay, it has amplitude A1 and this is wave number 2 and it starts maybe after some time. Okay, so this is having amplitude A2 and I superimpose both of them. So when I superimpose both of them, I'll get nothing but the resultant, and the resultant could be anything like this. I'll call this as AR. The way to find resultant in general is like this. First, I'll check that there is some path difference. You can see both the waves do not start together. So there is some path difference over here. This is nothing but delta x, which is path difference. Path difference leads us to phase difference. So phase difference is 2 pi by lambda into delta x. Once I get phase difference, you draw the vectors of amplitudes which are called as phasors. You would have studied this back in 11th standard. So those of you who do not know it, forget it for now. Maybe you will learn it later on when you watch my lecture series of SHM, or you can watch my recorded classes of Flash series as well. So you take you take amplitude of wave 1, let's say A1. The length of this is same as the amplitude. Whatever is the amplitude is the length of that vector. The next vector, amplitude A2, will be shown at an angle of del phi, whatever is the angle between them. So you can show amplitude 2 over here, and this over here is basically the phase difference. The resultant of these two, you use either parallelogram law or the triangle law, it's completely up to you, but the resultant is nothing but, the amplitude of the resultant wave. That's how you get it. That means all your vector formulas are useful. So AR will be nothing but root of A1 square plus A2 square plus 2A1 A2 cos del phi. So very, very important formula out here. Yep. Is that clear? Yep. Now, there is something which is also related to intensities which you must know. Now, everybody knows this fact that intensity, I have told this again and again, is always proportional to the square of the amplitude. Hence, if this wave has intensity I1, this wave has intensity I2, and this resultant wave has intensity IR, then the intensity formula is given in a very similar form. The intensity of the resultant wave is I1 plus I2 plus 2 root I1 I2, and outside the root you have cos del phi. It's very, very similar, but you do not have the big root outside. Okay, so the root is only there over here. IR is I1 plus I2 plus 2 root I1 I2 cos del phi. Very, very important. Yes, Ramya, don't worry. Your trust, your love will make sure somehow or the other you will not just crack JEE but also ace JEE. Now, you can also remember some specific cases. I'll tell you what those specific cases are, which might save you some time in the examination. For example, let's talk about constructive interference. In case of constructive interference, my warriors, what is my del phi? My del phi is, think about it, 0 or 2 pi radians. So that means cos 0 will become 1. If cos 0 is 1, then this is nothing but, a1 square plus a2 square plus 2a1 a2. It's the expansion of a plus b whole square. If you see, cos phi has become 1, so it is expansion of a plus b whole square. So when you take the root of it, it will just be a1 plus a2, and guess what this will become? This resultant intensity will become, because cos phi has become 1, this is actually speaking root I1 plus root I2's whole square. Just observe this, root I1 plus root I2 whole square. Just think about it. Root I1 plus a plus b whole square is a square plus b square plus 2ab cos theta. So this is nothing but root I1 plus root I2 whole square. Helpful many times. Very, very helpful. Same way, you can also remember destructive interference. So when you have destructive interference, del phi is obviously pi radians, resultant amplitude is modulus of a1 minus a2, and the intensity of the resultant, remember cos 180 is minus 1, so the only thing which has come over here is that negative sign, and here also you will get root I1 minus root I2 whole square. That's the only change. Correcto. Beautiful. Amazing. Okay, I know a lot of you have board examinations, and I'm really proud and happy that so many of you are turning up in spite of your board examinations, and that's the true spirit of JEE aspirant. Doesn't matter what is happening around, you should always attend your JEE classes. Perfecto. So that's what it is. Let's start solving some questions. I have given you all these things, in the theory slides, which you can download from our Telegram channel link. Yep. Now, if there are two waves, Come on, let's start these questions in rapid fire mode. Come on, my warriors. If there are two waves given by this and they meet at a point, they interfere, what is the amplitude of the resultant wave going to be? Wow, Pilla, Vandal, I will be very happy when you can do that. All the best and my full support to all the students who are fully enthusiastic and fully motivated to crack JEE, because that's what this channel and my teachings are all about. Okay, Nikhil saying B. Let's figure this out, whether it is A, B, C or D. So you can see this is basically amplitude A1. This is nothing but amplitude A2. This is sine omega t. This is sine omega t plus pi by 3. So naturally, this is your phase difference. Two waves having a phase difference of pi by 3. So the amplitude of the resultant wave will be root of A1 square plus A2 square plus 2 into A1 into A2 into cos pi by 3. So this will become root of 4 square is 16, 3 square is 9 plus 2 into 4 into 3. Cos of 60 is nothing but half. So this 2 and this 2 will go. Now this will become 16 plus 9, 25 and 4 into 3, 12. So 25 plus 12 is 37. Root of 37 is approximately 6 point something. Okay, 6 point something, but you can see in the question will be about, matlab nearly. So the correct answer will be option C, which is 6. Done, done, done. Yep, it is 60 degrees. Be careful about it. It's nearly close to 6. Very good. Let's move on to the next question coming up on your screen. Option C was correct. Now, two coherent monochromatic light beams of intensities I and 4I meet, superimposed. The maximum and the minimum possible intensities in the resulting beam are. Let's try to do this. First, let's go to the maximum. When I'm talking about maximum, that means I'm talking about constructive interference. So when I'm talking about constructive interference, think about it. What will happen? The phase difference is 0, right? Their phase difference is 0 or 2 pi and so on and so forth. And I had given you that formula. I max will be nothing but root of I1 plus root of I2 whole square. So let's use this and see what do we get. I1 is I, I2 is nothing but 4I and this whole square. So basically root of 4 is 2, 2 plus 1 is 3. So this will become 3 root I whole square, which will make it 9I. So the maximum intensity comes out to be 9I. Okay, if they interfere constructively. But in order to find the minimum possible intensity, that means I'm talking about destructive interference. And when I talk about destructive interference, the phase difference will be opposite out of phase pi radians. So the minimum intensity will be root I1 minus root I2 whole square. So it will be root of I minus root of 4I whole square. Now root of 4 is 2. 1 minus 2 is minus 1. So anyways, minus root I whole square. Square of a negative number will make it positive. So it doesn't matter. So this will just become I. So this is nothing but the least intensity which is possible. Very good. Now let's talk about the last situation, because this is going to be like an advanced question. What if the sources are incoherent? You have not seen the formula for incoherent sources. What to do in that case? I'll teach you the special trick. See, all these formulas are applicable when the sources are predictable, in sync, and they are coherent basically. But when they are incoherent, remember, you cannot use any of these formulas. Yes. So when incoherent sources are there, the intensity of the resultant wave does not follow this formula. I1 plus I2 plus 2 root I1 I2 cos del phi. No, this is not valid. In fact, the intensity of the resultant is just given by I1 plus I2. Just simple addition of intensities. That's all. Simple addition of intensities. Remember, when interference occurs, constructive or destructive, intensities never add. In fact, amplitudes add. So many of you would have made that mistake. Sir, I know what it is. I plus 4i is 5i is maximum intensity and least is 4i minus i, which is 3i. No, they are not the correct answers. You cannot add intensities. You can add, subtract amplitudes for constructive and destructive interference. Intensities are proportional to the square of the amplitudes, and that's where many of you make mistakes. Did you understand where you made those mistakes, Pilla Vandal? Yeah. So be careful. Now, the only time you can add intensities is when they are incoherent. You just do the simple addition, and that will be nothing but I plus 4i, which is just going to give you 5i. In fact, if you notice, 5i is the average value of minimum and maximum, and it should be. Reason? Very simple. Because they are incoherent sources, sometimes they will be in sync, constructive. Sometimes they will be destructive. Again, intermediate, constructive, destructive, constructive, destructive, intermediate. So it will average out. So what is the average of 9i and i? 9i plus i is 10i divided by 2, which is 5i. So it will always be the average, and that's why you'll get it as just i1 plus i2. Yeah. Okay, very good, Vandal. If you said it for incoherent, then it's correct. Perfect. V is equal to f lambda. Yes, it is correct, Ramya Balaji. Very true. It is correct. That is true for any wave, be it light, sound, or anything. So 9i, I, and 5i. What a brilliant question. And let's move on to the next question coming up on your screen now. Three waves are interfering and they have same frequency, but their amplitudes are different, 10, 4, and 7 micrometer. Their successive phase difference is pi by 2 radian. What is the amplitude of the resultant wave? Yes, very true, Suhani. If you take the average, you will always get the answer, but you should take the average of the maximum and the minimum. That's what you should do. But that is a lengthier step. Instead, I have given you a shortcut, Suhani. What is the shortcut? Just add their intensities. That's it. Plain and simple. Okay, you don't have to take the average also. Alright. So let's try to do this. How do you find the resultant? Either using the resultant formula, but that is only for 2 waves. Here we have 3 waves. But I know the general method. It's vector addition. So treat them like vectors and solve the question. You have one vector of length 10. The next vector of 4 is making an angle of 90 degrees. So this is a vector of length 4. The next vector makes an angle of 90 with the 4 vector and has a length of 7. These are the 3 amplitudes phasor diagram. Yep, and this is 90, this is 90. I think first let's get rid of 10 and 7 because they are opposite to each other. So let's not worry about that 4. But this 10 minus 7 will basically give you 3, which is at an angle of 90 degrees. Correct? So this 3 has come from 10 minus 7. Now 4 and 3 together, I think you can just do Pythagoras. This will give you 5 because right angle triangle, right? 4 and 3. 5 is 4 square plus 3 squares root. So the correct answer should be option B, 5. Done. Very good, Vandal. Excellent. No, it's not yet started. The JEE form filling has not yet started. As soon as it starts and as soon as the dates are announced, I will definitely let you guys know. I am also waiting for it. Trust me. Option B is correct. Moving on to the next question coming up on your screen. What do we have? 2 sources, S1 and S2. They are coherent and frequency F. Find the frequency for which, if you are at this point, the waves meet constructively, and second question is for destructive interference. So let me make you visualize this first. So source 1 produces some wave, okay, it reaches point P, and source 2 also produces some wave and it also reaches P, but they don't reach simultaneously. Why? Because this has to travel shorter distance, this has to travel longer distance. So how do you find if it is constructive or destructive? The main thing you should do is first find out path difference. Path difference will give you all the answers. So let's start with that. Okay. So what do you think is the path difference? This has to travel only S1P. This has to travel longer distance. So longer minus shorter will give you the difference of the path. So it will be S2P minus S1P. Now what is S2P? This length. Oh, this is 3, this is 4. Obviously this will be 5 meters. Is the hypotenuse, right? 4, 3, yeah, hypotenuse, Pythagorean triplet. This is 5. So S2P is 5. S1P is nothing but 3. So naturally it will become 2 meters. Fair enough. Understood? Clear? Okay? Yes, Suwani, that was easy, right? Okay. So let's see how to solve this now. Now let's do this. For constructive interference. Oh, before that, one small thing. I do not know the wavelength. So let me just quickly figure out what the wavelength of that light is. Okay, this was one thing. To find wavelength, speed of light is frequency into wavelength. So therefore, wavelength is speed of light divided by frequency. So this is another important thing which I might need for solving the question. Okay. Now, for constructive interference, we know that the path difference must be integral multiples of lambda. I have just told this to you. N lambda, 1 lambda, 2 lambda, 3 lambda. All these conditions give you constructive interference. So let's use this condition and see what happens. Delta x is 2. Okay, so let me just put 2 over here. N is as it is. What is lambda? Lambda is C by F. So let me just put C by F. But I think we need the frequency. So we need the frequency. So just shift it around. So F will be N times C divided by 2. That's it. That is our final answer. All the frequencies which are integral multiples of speed of light by 2 are allowed for constructive interference. So all these frequencies, if they meet at point P, if somebody is standing there, light will interfere constructively, it will be bright. If it is sound, it will be loud. That's what it is. Okay. Yes, Sweta, we'll be doing MCQs for the first term examinations just probably this week onwards. Yep. Yes, and second case, somebody has already put up the answers. Let's see whether the second answer is also correct or not. So, for destructive interference, what's the condition? Delta x is odd times lambda by 2. What is delta x? 2. What is odd number? 2n plus 1. Any number 2n plus 1 form is odd number. Lambda is C by F and 2 is as it is. So, F will be equal to 2n plus 1 into C divided by 2 into 2, 4 F. So that's for destructive interference. Done, done, done. Thank you, Abhishek Priyam, so much. Here n is even, no, n is any integral. N is any integer, okay? N is any integer. That even comes only in case of phase difference, not in path difference. 2 pi is one wavelength. So it comes in phase difference, not in path difference. Keep that in mind. Alrighty. Moving on to the next one. Yes, those are the correct answers. Just now we got that. Beautiful. Hi, Fahim. How 4f? 2 into 2 is 4, Ganpati. There was a 2 on the top, 2 below. So 2 into 2 became 4. Just rewind back a little bit, you will find it. Oh, did I put f in the denominator by mistake? No, f was not in the denominator. My bad. In case I had put it, please ignore. Okay. So f will be, this thing, 2n plus 1 into C and 4 into, that's it. Yeah, I think I put f also again over here, that f had shifted up here. Yes, so that's it. C by 4. Okay, so this should be the correct answer. Okay, cool. Is that understood? Can we move ahead? All right. So what do we have over here? Wow, this is a question on circles and coherent sources are placed on the diameter of a circle of radius r. Separation is given and the question is the sources emit identical wavelengths each. The number of points on the circle with maximum intensity is. Two sources are placed on the diameter of a circle. Separation is 5 wavelength. Lambda is the wavelength of light. On that circle, how many places will you get constructive interference, maximum intensity basically? So let's start by the diagram. Here's how the diagram looks like. And let me just show the two sources out here. Let's say this is source 1 and this is source 2. And the separation between them obviously is 5 times lambda. This is S1 and this is S2. Now I want you to realize this. This is source 1, this is source 2. There is a separation between them. Okay. Now when you are anywhere on that circle, let's say at this point, one wave has to travel maybe more or less than the other. So that creates a path difference. Now if you observe all the points on the circle, there are 2 or 3 critical points which if you solve, will solve the entire puzzle. How to do that? Akhila will start one shots for term 1 examination related stuff now, but for term 2, it will only start after the term 2 syllabus is completed. Now, what I will do, just imagine if I'm on the perpendicular bisector. That means if I'm here, this wave and this wave both will reach simultaneously. So delta x will be 0, right? Understood? If I'm here or here, my path difference will be 0 lambda. Is that making sense to you? Because both the waves will reach simultaneously. But if I am here on that line, this wave will travel this much distance, this wave will only travel this much distance. Do you see the difference of the path is exactly this much, which is nothing but 5 lambda? Exactly 5 lambda. So this is 5 lambda over here, and exactly over here will also be 5 lambda, because this source and this source, when they emit waves, the difference of the path will be 5 lambda. Perfecto. Now it's just about counting. Think, if there is 0 lambda here, 0 lambda here, 5 lambda here, 5 lambda here, just mark the other numbers. What will the other numbers be? This will be 1 lambda somewhere here, 2 lambda, 3 lambda, 4 lambda, here 4 lambda, 3 lambda, 2 lambda, 1 lambda, 0 lambda, 1 lambda, 2 lambda, 3 lambda, 4 lambda, again 5 lambda, then again 4 lambda, 3 lambda, 2 lambda, 1 lambda. Just count it, it's very easy. Very good, Vandal. Swani, this will go until 9 o'clock. Yep. It's nothing but, yes, it is nothing but option A, which is 20. Perfecto, perfecto. Excelente. Excelente. So the correct answer is 20. Oh, and I forgot to tell you one more thing. Yep. In case you do not know, when you're watching these lectures, there is a link for registering for Vedantu's Mega Scholarship Admission Test. So click on this link which is there in the description box. You will be able to register for the scholarship exam where you can win lots of prizes and assured scholarships right from 15% to 100%. So do not miss this. It's free of registration. You will get to know where you stand and you will get assured scholarships from a pool of over 100 crores. Also, you will get chances to win iPads, Kindles, your headphones and bags and so many other exciting prizes. So I'm pretty sure you don't want to miss that. Okay, so that's Vedantu Scholarship Admission Test. Yeah, make sure you register for it. It's available on all Wednesdays at 8 o'clock. Let's move on to the next one. Oh, did I ever watch my lecture in 0.25 speed? No. Maybe I think anybody's lecture in 0.25 speed or even in 4x or 3x speed will be funny. Trust me on that. Do I like social sciences? I never used to like social sciences when I was in school. But let me tell you, I realized the importance of social sciences, civics, geography when you actually grow up. The problem is the way it is being taught. You do not really understand the practical implications of social sciences until you start seeing the actual world around you, start following the news and politics and history and all of that. So probably it's just the lack of interest or the lack of proper teaching which has created that created that hatred towards that subject. All right, now let's go to the last part, which is geometrical path length and optical path length. See, when light travels from one point to the other, it goes, let's say, with speed of light which is almost 3 lakh kilometers per second. But imagine if light has to travel through a glass slab or any medium which the speed of light is less, because whenever light enters a medium which is denser, the speed becomes less, and everything is denser than vacuum. So when light enters any transparent medium, the speed goes down, so it will travel less distance. Now the problem is, let's say I want to compare two waves. For example, wave number 1, okay, it travels without the glass slab. Okay, it travels without the glass slab. Wave number 2 has to travel from that glass slab. Now what will happen is, the wave number 1 will travel at constant speed of c, but this wave 2, as soon as it enters the glass medium, the speed of light will decrease, and because of which, by the time it comes out, you will see that there is some lag which is created. That lag is because you have slowed it down. Yes, think of two runners, Andu and Pandu, or Pandu and Champa, or Laddu and Gundu. Okay, so one runner is constantly going on a road. The second runner has to go through a marshy land or through sand or some obstacles. So obviously there will be a lag created. Now, what is the meaning of optical path? The optical path meaning is how much is the equivalent length, okay, which the other light will travel as compared to the light which is traveling in the medium. I'll tell you again. The light which is traveling through the medium, okay, when it goes from here to here, let's say from t is equal to 0 to t is equal to t. In this time, how much distance will the other ray of light travel which is not traveling in that medium? So obviously that other ray of light which starts here, it would have traveled more distance in that same time. This is called as optical path. Okay, this is the equivalent path. You can think of this like the equivalent path. This is basically the geometrical path. This is nothing but the geometrical path. That means the actual path taken by the light. This is the equivalent path. Because in the same time, how much will the light which is traveling from outside travel? That's it. Yep. Is that clear? Oh my God, you are an offline class student 3 years ago and you're still watching it. That means you really love the subject. So glad that you're here. How much time should you spend for JEE Advanced questions as a dropper? It should be at least 70 to 80% of your time should be just solving questions. Hardly 20% should be making notes, revising it, or probably gathering more theory or something like that. Yeah, around 80% should be just solving problems for a dropper student. Now, about from that percentage, JEE Advanced can be 50%, it can be 60% depending on your confidence level. If you are very confident, then 90 to 80% of the problems should be JEE Advanced level. But if you are not so confident, then it should be 20 to 30% of the problems should be JEE Advanced level. Okay, depends on your last year's percentiles and all of that. So we can find this out very easily. Now, if the thickness of the slab is L, okay, if the thickness of the slab is L, what do you need to do? First, figure out how much time does it spend here. And for that, I have a simple trick. Speed of light is c. Inside a medium, it will be c by mu. Mu is refractive index. Why am I dividing it? Because it's a denser medium, so it will reduce mu times. Now, this distance, using this formula, distance is speed into time, which you have been learning in lower grades as well. That distance is length L. Speed is c by mu into t. From this, I got the value of time as L mu by c. Okay. Now, for this situation, the optical path length. So let's try to do this. So optical path. Okay, optical path will be this speed into time. Okay, distance is speed into time. So c into t. Wait a minute, t is obtained over here. So c into L mu divided by c. C cancels, so it will become L mu. So optical path length is the actual path into mu. Very easy to remember. Very easy to remember. Understood? IIT Tirupati is decent enough, Himavarshini, but I'm pretty sure if you are a JEE 2022 student, you can definitely aim for something else better. It's a new college, not so great placements. Now, if you talk about the path difference, then that is also very easy. This is L mu, this is L. So delta x will be L mu minus L, which is L bracket mu minus 1. So that's how you can find it out. Is that clear? Is that clear? Oh my God, you are in BT from Pune. Oh my God, high five. Okay, I'm not sure what's your actual name. And then I don't know whether I taught you actually, or were you in some other branch or something. All right, all right. And where are you now? How are you doing these days? It's going to be interesting to know that. Oh, remember that formula is always confusing. It is always L into mu minus 1. That 1 by mu comes in case of, the lateral shift generated by a glass slab, that it becomes reciprocal. And for prisms, that, what do you say? The minimum deviation, there you have angle of prism into mu minus 1. Yep. Okay. So that's what it is. Okay, so 3 formulas which are very similar to each other but often lead to a lot of confusion. Oh my god, I had taught you. I'm so happy to see you. Okay, this is interesting. Last time also somebody else had come. IIT Madras 3rd year. Oh my god, the best IIT ranking was IIT Madras this year, and I'm so proud of you. Guys, my ex-student is here and you should derive some motivation from him. Very good. Very good. You should definitely feel proud and look up to your seniors, and I'm pretty sure that many of you are going to crack it next year. So guys, just stay tuned, stay focused, just keep on solving lots of problems, watch my classes, trust me, you will crack it. All right, and just keep on taking motivation from YouTube channels like this, and your seniors and your teachers, whoever are teaching you in your regular coaching as well. So we have a slab of thickness and some refractive index. It is placed between 2 points A and B as shown. What is the optical path length? What's the equivalent path? See, the geometrical path is x plus L plus y. This is the actual length. If you add that, you will get geometrical path. But the equivalent path is something else, because the light slows down over here. So what's the equivalent path? That's the question. Time required to solve one JEE advanced question from coaching material depends, Satish. When you are solving it at home, don't keep time limits. Try till the end, no matter how much time it takes. Even if it takes 1 day, it's okay. But you should solve it on your own. Take hints if needed. Never watch the complete solution, especially for JEE advanced. Okay, so that's what it is. Yes, no, I do know. Obviously, I'm in coaching industry for a long time now. I know it. Okay, so let's see how to solve this. It's very easy. First of all, here the light is traveling through air. This is traveling through some medium, again in air. The only equivalent optical path will be over here. So here it will still be x because it's still in air. Here it will be length of the slab into mu, which is 1.5 into L. And here the equivalent optical path is same as that one, which is y. So x plus y. So x plus y plus 1.5 L. Is that answer there? Yes, it is. It is option C. You can check that out. 1.5 is 3 by 2. So x plus y plus 3 by 2 times of t. So that's the equivalent path length of this entire system. Moving on to the next one. Oh my god. Okay. So what do we have? Don't get scared by the length of the question. Always when questions look big, they are actually very easy. So the first ray travels through length L1, refractive index mu1. The second ray travels through length L2, refractive index mu2. Both the waves then meet, interfere. The question is, what's the phase difference? Not path difference. Hi Sailaja. What's the phase difference? To calculate phase difference, we need path difference. And to calculate path difference, let me just visualize this first. Okay, we have slab 1, we have slab 2, and this is mu1, length L1, this is mu2, this is length L2. Light over here goes like this and goes here like this. Okay, now obviously there will be some path difference between them. How to get that path difference? Here is a simple hint. Find the equivalent length here, find the equivalent length here. Find the equivalent lengths for both these scenarios and just subtract them. That will give you the path difference when they finally come out. Understood? So what is the equivalent path length over here? The equivalent path length is mu1 L1. Equivalent path length over here will be mu2 L2. So the path difference will be mu1 L1 minus mu2 L2. Whichever is bigger, just take the mod value or else. Now, in order to calculate phase difference, what do you do, my warriors? 2 pi by lambda into delta x. So that's it. 2 pi by lambda delta x is as it is over there, mu1 L1 minus mu2 L2. That's the final answer. I think it is there right over here. mu1 L1 minus mu2 L2. Very good. Okay. So Satish, nobody in this world can predict what is the question going to be in JEE Advanced. Okay, you cannot. Okay. So Sailaja, collisions chapter is already done. Just wait for a moment. I'll show you where to find it. It's there in the playlist. I just completed it before rotation and all of that. So watch it. Aram se. Okay. 4 classes at least are there on collisions and center of mass and all of that. Okay. Last question for today. So the optical path of a light is same if it goes through glass or water. The refractive index of water is given. What is the refractive index of glass? Interesting question. So the optical path length in glass is same as the optical path length in water. That's what the question says. What is the formula for optical length? Mu into the thickness of the slab. So here it will be mu of glass into length of glass. Here it will be mu of water into length of the water thickness. What do we need to find? Refractive index of the glass. Okay, so this is something which I don't know. Do I know the length of the glass? I think so. 2 centimeters of glass. So this length is 2 centimeters. Refractive index of water? Yes, it is given 1.33, which is 4 by 3. Okay, or approximately the same. Length of water, I think that's given to be 2.25. Now this is simple math. So this 2 and this 4 will go like this. So it will become 2 by 3. And what is 2.25? So divided by 4, that means it will be 9 by 4. So this 2 goes, this 3 goes. So 3 by 2, that means the answer should be 1.5. Okay, so that's how you can do it. Oh my god, you still remember some of these examples. Yes, obviously physics won't change. I mean, the 3 laws will remain 3 laws even after 100 years, I hope. Alright, so glad that you remember this. I mean, I also remember some of the examples which I learned during my 11th and 12th. I don't know, whatever you learn in your childhood, right? It just stays. It creates such a big impact and it just stays in your memory. So that's why I say, you always, never stop learning, keep learning. This is a very impactful age and your learning ability slowly decreases as you age as well. Okay. Okay. So, oh my god, once my notes got stolen. Yep, I do remember. Yes. Now, thankfully, I have my digital notes and I learned from that incident and slowly I gathered some money and bought an iPad and then I made all my notes digital so that it does not get stolen, and plus I created a backup just in case my digital device got stolen. Yep. So this is your first homework question. Please post the answers in the comment section. That will obviously, give you confidence about this chapter. Okay, this is the next question. Solve this, put up the answers in the comment section again, and the solutions will be available on the Telegram channel. The link again is there in the description box. Remember one thing, if you want to study under me, want to take up my micro courses, need your lessons in English, you need test series, you need assignments on a daily basis, you need that additional material, and you need my level of teaching, then you need to definitely consider pro subscription, because one thing about Vedantu, you don't have to travel anywhere. Number 2, you have that flexibility of choosing your own timing to watch. In case you want to watch it recorded, you can make your own schedule. You have that flexibility, freedom, plus the test reports are truly amazing. Just watch it. I mean, you'll be blown away. I mean, like crazily. So what I would suggest is try out the pro subscription for at least 15 days. You can check it out over here, class 12th pro subscription. Just click on this link. You will see there are 3 versions, Lite, Classic, Plus. You get everything in the Lite version, but some students, need doubt solving on the mobile app. So you go for the Classic version. In the Plus version, you get personal mentorship and guide. Even if you choose the Lite version and the cost is 36,000 for the entire thing. Okay, you can try it out for 15 days using my coupon code SHHPR. You get 10% off at a very good price of 1,530 rupees. Try it out. If you don't like it, you're free to leave. But try it out, and I'm pretty sure you'll enjoy it and you'll continue it. Okay, so go ahead, check it out, and do not forget to post the answers in the comment section. It was a lovely session with all of you. I'll be doing Young's double slit experiment in the next class. Okay, and make sure that you attend the classes in spite of your board examinations nearby. We'll be doing lots and lots of revision for the term 1 CBSE 12th standard examination as well. So stay tuned, and do not forget to smash the like and hit the subscribe button out there. Thank you, Sweta. Thank you, Basti. Thank you, everyone. Thank you, my ex-students out here. Very good. I'm so proud of all of you. Keep working and keep studying. Hasta la vista. This was Shreyas here.